All right, welcome back. So now let's do this example here. And so we've got a common logs and natural logs. And so you can tell these are common logs because there's no subscript here for the base. So it's assumed to be 10. Okay, so these are log base 10. So we're taking the common log of 100,000. Okay, so again, we're looking for an exponent, right? So we're looking for an exponent. So we're going to raise 10 to what power to equal 100,000, right? So again, every time you multiply by 10, you're adding a zero, right? So you can just count the number of zeros if you wish, right? So in this case, it'll be 5. Okay, or you use the equivalence property, right? And rewrite the 100,000 as 10 to the 5th, and then the equivalence property tells us that x has to equal 5, right? And again here, we're looking at how many places the decimal place needs to move, right? So here, it moved to the left, right? So in this case here, we're asking, okay, again, what power does x have to be? So we have to raise 10 to what power in order to get to 0.001. So now we're moving to the left. Remember, if you divide by powers of 10, that's a negative exponent, right? So that's 10 to the negative 1, right? So again, I'm just throwing some little tips out there, okay? So again, if I'm at 10, right, then negative 1 would be 1/10, which would be here. Negative 2 would be 1/100th, and negative 3 would be here. So we can look at it that way, okay? Or we know that we need to solve this, right? So we can count the decimal places, and so we're going to the left, which would be negative, or we could say, okay, well, how can I write this as a power of 10? Well, if I go back, right, actually, hold on a second, 10, yeah, that's right. So here, if I look at it this way, how do I write this? Right, so I could just write this as, okay, how would I write this as a power of 10? Well, if I'm at 1, right, if I just 1 and there's the decimal point, and I have to move the decimal point 1, 2, 3, right? That means I'm dividing by 10 3 times. So I can write this as 10 to the negative third, right? That's the same thing. And then use the equivalence property, say, okay, well, now that I've gotten written as two exponentials with the same base, I know that x has to equal negative 3. Now, we're going to do the same thing with the natural logs, but we're just saying, hey, this is log base e. So this is what? Log base e, right? So I could say, okay, well, what do I have to raise e to? So if I have e raised to what power is going to give me e to the 4th, right? Because that's what I have. So the natural log of e to the 4th. So since this is base e, I can write it as an exponential e to the x, and I can answer, okay, what exponent of e will give me this? Well, then it's easy because the equivalence property will tell us x equals 4. So this natural log is equal to 4. Just like this common log of this number is equal to -3. And the log of 100,000 is equal to 5. Okay, now what about this one? Well, this is, again, base e. So I'm asking myself, e to what power is going to give me 1 over e? Well, if this is +1, that'll give me e. But this is the reciprocal of e, so this would have to be negative to convert this to this. So again, I can rewrite this as well, right? 1 over e is the same as e to the -1. And then I can use the equivalence property. And that tells me x equals -1, which means the natural log of 1 over e is -1. All right. Practice.